So welcome to Truth Tables for Compound Propositions. Now, to be honest with you, you're going to get away with something that you know of not for very long. And the exercise I'm about to show you, and probably shows up in homework, you know truth tables. Other than the connectives have been changed slightly from what you have in programming to what we have in discrete math. Other than that, and a couple other new gates as well. Other than that, there really isn't a big change between what we're doing now and, frankly, well, what you've done in programming. That's going to change because our equations that we're going to be given here in a moment, they're going to get bigger and more expansive, and we're going to be given rules and equivalences to try to, frankly, make it a lot faster for us to solve or at least reduce. So enjoy what you're about to get now because it won't last for very long. So here's a truth table for our equation of P or Q, and it's going to imply a negated R. Most of this is going to look pretty familiar to what you've done before. This time we have three variables because of P, Q, and R. But notice, by the way, we always start with actually all trues and then all falses down to the bottom. So notice the pattern that we have here. So be very, very careful. It's always reversed in your book and many examples that you'll see online or whatever. We're first, because of order of operations, going to take care of the negated R. Then we're going to go ahead and do our P or Q. Now again, remember, the equation is the one that dictates everything. And then we're going to do the implication for that. Now, to be honest with you, I'd rather swap these two, but I'm going to leave them there for now. Just remember, when we do an implication, we have true, the condition was met, but then we didn't follow up with it, so we broke a promise. That's a problem. That's why that's false. We have true, and then we did follow up with it. That's true, so we're good to go there. We have another false, true, and then a false. So that's going to make that false. We have two trues, and use the table that we went over for implications on exactly what our responses for is this, or for what this would be. So the last two parts I want to highlight here because these are the vacuously true. We have a false, meaning the condition was never met. So do we ever break a problem? No. So that's why that's true. Here's another one, same idea as false, even though response is true. It's still vacuously true because, hey, the condition was never met. Do we break any promises? No. So that's your overall solution for this truth table, but enjoy it now. It's not going to last long.